All right, pre-cal. We are now moving on to the next kind of right triangle problem. So now, rather than finding all of our trig ratios, we've got to pick the best one to find what we're being asked to find. Okay, so this can get a little tricky. So just stay with me here. All right, so find the value of x, round to the nearest tenth if necessary. Okay, so now we're not finding exact values. We're now going to be finding decimal values. So you are going to need a calculator for this. I'm going to use the Desmos scientific calculator. If you have a TI-84 or a TI-83 or something like that, I will tell you how to operate that. Okay, so for these, now we're not finding all of the trig ratios. We're just finding, for this problem right here, we're finding what the value of this leg of the right triangle is. So we have to figure out which of our trig ratios is the best. Do we want to use sine? Do we want to use cosine? Or do we want to use tangent? The best way to do this is to look at the angle. What do you have in reference to that angle? Well, we don't have the opposite side. We don't know what it is, and since we don't know x, we can't use the Pythagorean theorem. So that is going to automatically discount using the sine ratio because it involves using the opposite side and hypotenuse. It also eliminates tangent because tangent is opposite over adjacent. That leaves us with cosine. So I'm going to write cosine of 42 degrees. Remember, sine, cosine, and tangent of an angle every time, whether it's known or unknown. This time I know the angle. I'm not using theta now. I'm using the measure of the angle. So cosine of 42 degrees equals adjacent, that's this side, over hypotenuse, that's the 18. Once you do that, now you've got an equation. So it is an equation that I need to solve for x. So I am going to write cosine of 42 degrees over 1, and that is equal to x over 18. Now we're going to do what everybody tries to do all the time in the wrong place. We are going to cross multiply because you can do that over an equal sign. So I'm going to do that. X times 1 is x. And then I've got 18 times the cosine of 42 degrees. All right, your calculator will find the cosine of 42 degrees for you. Remember, the cosine of 42 degrees is a ratio of values. So I'm going to find this, but I have to use my calculator to find it. If you have a TI calculator, or a Casio. You may have, I don't know about the Casio, you may have to change the mode in it, I'm not sure. But for TI, you have to go to the mode button and you have to put it in degree mode. All right, or this won't work. Okay, so now I'm going to go to my calculator, 18, I'm going to type in 18 times the cosine of 42. And that's what I get. I get 13 point blah, 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 blah. So I am rounding to the nearest tenth, so that is 1 decimal place. So I'm just going to round that 3 to a 4 right here after the decimal. So I am going to go back in here and write that x is approximately, well, I'm just going to write equal, but it is approximately because we're rounding, 13.4. And of course, I've not given you any units here, so I'm just going to write units. Magic. Okay, let's do the next one. Now I've got the angle 29. Remember, I'm always going to look at the angle to figure out how to set this up. So am I going to use sine, cosine, or tangent? All right, so here's x. That's what I'm looking for. So my angle in relation to x and the other side that I have, well, I don't have the hypotenuse, so that eliminates sine and cosine. That leaves me with tangent. So tangent of 29, there's the opposite side, this is the adjacent side. So I set up my equation, tangent of 29 degrees equals opposite over adjacent, just like that. Beautiful. Okay, so once we do that, I'm going to put tangent, oh man, I'm going to put tangent over 1, cross multiply, x equals 40 times the tangent of 29 degrees, And then I'm going to go to my calculator here, if I can do that right. Okay, I'm going to clear that. And I've got 40 times tangent of 29 degrees. And that gives me 22.2. All right, so x is approximately 22.2 units. Just like that. And I didn't give you a problem where you end up with x in the denominator. So I just want to show you what that would look like. Let me scroll down here and show you what that would look like. Let's say we ended up with something like 14 cosine of 10 degrees. No, that's not a good one. Okay, let's say we end up with cosine of 10 degrees equals, I don't know, 21 over x. If you end up with something like that, then you're still going to cross multiply, but now x is not going to be by itself. So you're going to have to divide by cosine of 10. And this is all calculator stuff, so hopefully that won't get too scary. Anyway, that's what you're going to do if you end up with x in the denominator. Okay, so now let's look at these equations, or these triangles, sorry. Use a trigonometric function to find the measure of theta, round to the nearest degree if necessary. All right, so for these, now you're looking for the angle. Notice that in these up here, we were looking for a side. That will change things a little bit, how we use it in the calculator, not how we set it up. All right, so again, I am going to look at sine, cosine, or tangent. Which one am I going to use? Again, look at theta and its relationship to the sides. We've got this side, and we've got this side right here. We do not have the hypotenuse. That means that we are not going to use sine or cosine. All right, that means we're going to use tangent. So tangent of theta, I'm using theta now because I don't have its measure. I'm finding its measure. So tangent of theta equals opposite, that's that, over adjacent, which is 11. Okay, so how are we going to do this in the calculator? Because ultimately, I want theta. I don't want tangent of theta. I know what tangent of theta is. It's 26 over 11. So if you're using a TI calculator, you're going to basically have to use tangent inverse, which is the second button in tangent of 26 divided by 11. But I am going to use my Desmos calculator. So for this one, I am going to use, let's see, there might be a function on here, tangent inverse, right there. Okay, so I have to go to the function button, and then tangent inverse, oh, poop, got to clear all that. Tangent inverse of 26 divided by 11, just like that. And then I get 67.06. So 67, this is degrees of an angle, so I'm just going to round it to a whole degree. So that's going to be 67 degrees. Magical. I knew you'd love it. Okay, we're going to do the same thing in the other ones. So look at what you've been given here. What am I going to use? Sine, cosine, or tangent? All right, so in relation to theta, I've got this side, which is the adjacent side, and I've got this side, which is the hypotenuse. So I don't have the opposite side. So that means I can eliminate sine and tangent here. So I'm going to find cosine of theta, which equals adjacent 5 over hypotenuse 12. Now I'm going to do the same thing. I'm going to use cosine inverse to find what theta is. So theta is going to equal, okay, I'm going to go back to my calculator, clear that, go to function, cosine inverse of 5 divided by 12, and that gives me 65.4 roughly, but it's angle measure, so I'm just going to round it to a whole degree. Dang it. 65 degrees, there we go. Okay, and here's our last one. Remember, I'm going to make my list here. so I can figure out what to use. Theta's right here, opposite and hypotenuse. So that means I'm going to use sine. So I've got sine theta is opposite over hypotenuse. So I've got to find sine inverse of 14 divided by 16. Go to your calculator again, clear that. Function sine inverse, go to the main, and then 14 divided by 16. And it gives me 61. So theta equals 61 degrees. And if you'll notice, all of these angles make perfect sense in your right triangle. So that's how you do that.